In this video, I'm going to show you the formulas that we use to propagate uncertainties. That is, the formula used to take uncertainties from one number and calculate the uncertainties in a new calculated quantity. So, let's do an example together. Let's consider that there are two bricks. So, we're going to have brick number 1 here, and brick 1 is length 10 centimeters with an uncertainty of 1 centimeter. And it has a height, b, which is 5 centimeters, also plus or minus 1 centimeter. And then our second brick is very similar to the first brick. Its length is the same as a, so 10 plus or minus 1, but its width is different. The width of the second brick is c, which is equal to 20 centimeters plus or minus 4 centimeters. Now, if I was to stack these two bricks on top of each other, I would want to know what is the resulting height. So, to do this, if I wanted to know, I would have to do the height of the first brick, which is b, plus the height of the second brick, which is c. So, to calculate this, I do 5 centimeters plus 20 centimeters, gives me 25 centimeters. But then the question is, what is the uncertainty on the answer? So, in this case, I look at my first uncertainty formula, which says if y equals a plus b, then, which we have here, our total combined height is brick b plus brick c, then the uncertainty is just the sum of the uncertainties. So it'll just be it'll just be the uncertainty in b plus the uncertainty in c. So 1 centimeter plus 4 centimeters is plus or minus 5 centimeters. So that is the uncertainty in their combined height. Now let's imagine that I wanted to calculate the area of brick A. So this area, surface area facing towards us here. So in this case, the area of the brick would be A times B. Now in this case, that would be 10 centimeters by 5 centimeters, which would be 50 square centimeters. But then the question is, how do I find the uncertainty? Well, the second formula here shows us that for multiplication or division, so if y equals a times b divided by c, anything multiplied or divided together, then we add the relative uncertainties. So I find the relative uncertainty in a, so that's delta a over a, and add the relative uncertainty in b. Now if there was a third quantity I was also multiplying, I'd also add its relative uncertainty. So the relative uncertainty in a is 1 over 10, which is 10%. And the relative uncertainty in b is 1 over 5, which is 20%. So I add these percentages together and I get 30%. So that is my relative uncertainty in a times b. But then I want to express this as an absolute uncertainty, so I'll then take 30% of the 50 centimeters squared to get 50 plus or minus 15 centimeters squared. Now finally, imagine that I had a different brick, and this brick is a by a. So in this particular case, if we wanted to find the area of that brick, which I'm going to call y, then the uncertainty in the area is just going to be given by n times the relative uncertainty in a, where n is the power that we are raising a to. So in this case, we are squaring a. Y is equal to a squared. So given that a is 10 centimeters, that is 100 centimeters. But then to figure out the uncertainty in y, the relative uncertainty in y is going to be equal to, so in this case, n is equal to 2, multiplied by the relative uncertainty in a, which is 1 over 10. So in this case, that is 2 over 10, which is 0.2, or 20%. So the relative error in y is 20%, and given that y is 100 centimeters squared, that means that it's going to be 100 plus or minus 20 centimeters squared as my final answer. Now that you've watched these videos, you should be able to find the uncertainty in a quantity that involves the addition, subtraction, multiplication or division of other quantities with uncertainty.